Today we're going to talk about what I call a bright future for broadband and why I use that phrasing and why I think you can start using it as well. Um, Another phrase I use to describe the situation that we find ourselves in is the perfect storm, and I mean that in a very positive way. It is a number of factors that really kind of all come together at this one point in time to allow us to build out really the broadband networks of the future. Um, the first of those, according to my little agenda here, we're going to address each one of these points, but the first of those is talking about that coming together of those factors, right? Starting with really a tremendous amount of public investment in broadband expansion, particularly in the rural areas. We're going to move on to some planning considerations. If you are considering upgrading an existing network, or if you have not hung fiber yet and you're thinking about getting into that, then here are some considerations that you might want to take some notes on to talk to your consulting engineering firms, your vendors, what have you. We're going to move on from that and talk about how do you get started, right? What are some of the steps and considerations that you want to make sure that you've got covered when it's time to actually pull the trigger and move forward. And then finally, what does the future hold, right? And how does building a network today help prepare you for that future? And those two questions or points are closely linked, right? You have a historic opportunity to build a network today, but you want to make sure that network is going to serve you years down the line, right? You don't want to have to come back 5 years from now and then do it all over again, particularly if the level of public investment isn't there at the time, right? So we'll talk about the future and what that holds. So first of all, why is broadband a big deal? Most of you are going to know the answer for this. In fact, probably all of you, but I'm going to put it up here on the board anyway so we can talk about it. COVID really was a very illuminating period for a number of reasons, but primarily with regard to broadband. It showed pretty much all of corporate America that working from home is a viable strategy. The folks that previously had to show up to an office can now, in some ways, be much more productive working from home. This means, of course, better broadband, more reliable broadband service. The next category is cloud gaming. Really, I like to talk about it in more of a virtual experience. Gaming is a multi-billion-dollar industry. There are folks that can that require a much higher level of service. So this is a service opportunity, right, to serve those folks that are into the gaming and also virtual reality experiences. The future of the internet, you know, it's a cloudy crystal ball, but most people believe that the future of the internet is going to be some type of virtual reality, whether that's a headset or some other type of projector or what have you. But instead of browsing on a website, you'll actually be walking the aisles at Amazon.com, right? Something like that in a virtual way. And that, of course, is going to drive usage. Health and telemedicine, pretty self-explanatory. During COVID, we never went to the doctor's office, but we had doctor visits and we had them in the living room. So very valuable, not just in a pandemic, but in rural areas where it might be an hour or two to the nearest clinic. Telemedicine can really make all the difference. Education is huge because if you, like me, if you've got kids in school, in college, you see how expensive it is to send them to that campus and spend that kind of money on an education. An increasing and significant percentage of folks are getting their degrees online now. And this just makes sense. We consume virtually everything online today. If you live in Arizona and you want a degree from the University of Maine, instead of going all the way across the country and finding an apartment and going through all of that, why not get that degree online? The advantage there to us as consumers is that it's a much more competitive marketplace, right? You don't have captive students on campus. You've potentially got students all around the world, and they have multiple universities with online degrees that they can shop for. So the dream and the hope is that that tuition starts coming down. But education is obviously going to be a big part of the future. And then the digital divide, right? We've been using this phrase for 10 years, 15 years now. And that is really the driver for all of the money that we're about to talk about. There are folks in this country that still do not have even reasonable speeds because of one reason or another, right? On home broadband. And we saw a lot of that during COVID. We saw stories about kids having to do their homework at a McDonald's parking lot and so forth because they couldn't go to school and they didn't have broadband at home. So that's the demand, and I'm sure you're seeing some or all of these. This is what's driving this market surge in serving and providing broadband. The money, if you haven't heard about the money that's coming down the pipe for rural broadband, then you've been living in a cave, right? There is all total right around $100 billion that's been proposed and funded between the federal government, state initiatives, and other initiatives. A lot of that has yet to even be distributed yet, right? And is going to be up for grabs, so to speak, in a number of different ways over the next several years, right? So the kinds of investment that we are seeing today and will see for the next, say, 5 years are truly historic. And I don't know that we certainly have never seen them before. And I don't know that we're ever going to see them again, at least in our lifetimes. So now is the time to, if you've ever considered building a broadband network, now is the time to look into that. And I'm sure a lot of you are already ahead of the game and moving forward with that. In many cases, we're hearing from utilities that want to become utelcos that they're paying 25 cents on the dollar to hang fiber, and that's hard to turn down, right? Really a tremendous opportunity. These monies typically come with some sort of requirement that the money you spend must be spent either on American products or on products made in friendly countries, right? It's kind of a positive way of saying that there are certain countries where the government doesn't want you to spend taxpayer dollars, right? And we're going to talk more about that as we go through. It's just something to be aware of. All right, so who are our customers out there in the rural market? I talked about a few of the drivers, right? Working from home, telemedicine, education, and so forth. But these are a number of the requirements that these 4 large categories have, right? So agriculture, for those of us in the rural spaces, it's pretty obvious, right, that agriculture is a technical field requiring reliable broadband, requiring a high degree of service delivery. For folks in the city, they probably think of it, not as technical, right? But anybody who's ever been inside a harvester knows how technical this business can be, right? So these are some of the requirements, right? Certainly reliability, security. They need to be able to connect on the move. The bandwidth is always going to be a requirement, right? They're always going to be driving higher and higher bandwidth. Low latency if your harvester is pulling down information, or your other farm equipment is pulling information from satellite imagery, or from some other type of sensor data to provide soil amendments, seed, and so forth, then that has to be a low latency connection, right? Manufacturing, manufacturing is not the first thing that comes to mind for a lot of people when you think of rural areas, but that is something we certainly need to be changing our minds about, because the rural areas have a number of really valuable aspects to them. Number one, the real estate is often much, much cheaper, right? This is why you see big data centers and so forth going out into the rural spaces, because one of their primary assets is their floor space, right? Their square footage. And that is much cheaper out in the rural areas than it is closer to urban areas. It's also generally safer. You also have a much more reliable, consistent, and loyal employee base out there. So a number of reasons why manufacturing is going to be a higher driver, or a more reliable driver. And of course, they have a long list of requirements that they're going to need out of their broadband. Where we're going with this is to drive home the point that broadband, or home connectivity, or internet connectivity, is a lot more today, and is certainly going to be a lot more in the future than simply a dedicated internet service, right? Here's a 1 gig internet service, right? And good luck with it, right? That may be okay with some customers, but consider that there are going to be customers that need a higher degree of reliability. So protected services, for instance, security, perhaps encrypted services where they're delivering healthcare data, or other types of sensitive data, and you need to be able to provide that encryption on a per service basis. And then, of course, that's a revenue opportunity for you. So providing that diversified services portfolio is what I'm driving at here, right? Something to consider in addition to just more bandwidth, right? Which is always going to be there. Education, we talked about. And then, of course, residential. Residential in the rural areas, a lot of time residential, that's an office. That may be a CEO's office, right? In a residential area. We have a lot of people that have moved out of the cities, out of the suburbs, and are operating not just work from home, but they are operating businesses out of their home, right? So being able to offer them that higher level of service for a higher level of revenue is obviously to your benefit. Okay. So planning considerations. These are some sort of the nuts and bolts of a data transport and broadband delivery network. Okay. So if you want to take some notes, scale and distance, right? This is a consideration because we have to get the signal from one side of your operation to the other, right? One side of your network to the other, one network to another, one county to another, one side of a college campus to another, what have you, right? So how much data do you need? And this is typically measured in gigabits, 1 gigabit, 10 gigabit, 100 gigabit networks are very common these days in terms of the backbone. We had a short window where 200 gig was an appropriate speed and still is providing good service, but the pricing for these components has come down so far that now instead of building a 100 gig network, you can build a 400 gig network for a pretty minor upcharge in the optics. And some of you right now are probably rolling your eyes and thinking, 400 gig, what am I going to do with that? Well, we typically say that every time there's a large increase in backbone speed, right? Oh my God, that's way too big, right? Well, if you are only paying a 25% upcharge over the market space, right? Not just ribbon, but really over all vendors, right? 400 gig technology has come down so far that there are compelling reasons to go ahead and build a 400 gig network that you can grow into. Okay, traffic engineering. So all of these diversified services that I've been talking about, right, for higher revenue potential, right? There's basic service at the bottom, but then there's low latency, encrypted, highly reliable services at the top, and everything in between. All of that requires traffic engineering. The devices need to know who's the important customer, what services have they purchased, and then how do I provision that, right? The other thing that has happened in terms of technology over the past few years is the advance of what we call the IP protocol stack. There are a number of new protocols that have been developed that are highly efficient, fairly straightforward to deploy, and provide much better service than in the past, right? One of them, just as an example, in the past, a protocol might provide a protected service where you have a working and protect, right? This goes back to the Sonnet days, right? You've got a working and protect path. Well, now there's a protocol that will allow you to protect a service all the way around your network, active and active, right? So no bandwidth is stranded. You've actually got two paths. And of course, you're charging more for that service, right? So the software part of networking as well as the hardware part has really come a long way across the last couple of years. With all of this new capability, there is an increasing need to simplify this, particularly in the rural areas, because rural providers, whether telecoms or utelcos, they don't have the kind of staff that you're going to see at a Verizon or a Windstream or what have you, right? Typically, it's a core group of folks that wear multiple hats, and they have to be experts in multiple areas. And so it's impingent upon us as the vendor community to provide you with the tools that will that will simplify that complexity. It will automate some of your tasks that were repetitive and requiring a lot of keystrokes and manual intervention, allowing you to copy and paste those in effect, so that it streamlines your process. This in turn makes it easier to troubleshoot, makes it easier to deploy services, and dramatically shortens your mean time to revenue, right? From order to actually starting to bill for that service. And then finally, this applies to everyone today. In the environment that we live in, security, there are now security officers at some companies, where in the past that was just part of the IT function. Now security is a multifold, defense in depth kind of discussion, where the more layers of security you have, the better. And this comes all the way from cybersecurity to physical security of your plant, your substations, your COs, and then all the way down to the data that goes across your fiber optic cable, right? Encrypting it so that even if somebody is able to tap in, that all they're going to get is gibberish, right? So these offerings are something that you want to certainly consider. I'm sure you are, and these are certainly things that we can help you with. And then the other aspect is the hardware piece, the equipment that Ribbon offers. We cut our teeth, if you will, initially as a company, providing IP optical solutions for the military agencies around the world, as well as utilities around the world. So we have a very high degree of quality and reliability built into the hardware and the software. Many of our components, where it's necessary, are FIPS level 2 compliant. FIPS level 2 is basically a government certification that talks about where the equipment is manufactured and does it have tamper resistance on it. Are there indicators if somebody has tampered with it? It is a physical level of security around the components. So a very high degree of reliability and security is built into ribbons solution. So let's talk about some more theoretical, high-level design characteristics. And this is just to kind of give you some of the lingo if you're not familiar with it, and then also kind of point out some of the truisms that I've discovered and are pretty common across the industry. When we talk about building a network, we typically talk about layers, layer 1, layer 2, layer 3, okay? So layer 1 is the optical layer. Sometimes it's also called the physical layer. This is your fiber and just the light pulses that go across it, okay? It's pretty straightforward. It works a lot like copper does. Copper moves data by moving electrons one way or another. Fiber optic cable uses light pulses that go on and off across your network, right? And that binary signal is turned into a data stream, if you will, right? Well, this is the most cost-efficient way to move data from one location to another. It is very low service oriented, meaning that there's not a whole lot of manipulation you can do with it. It's really kind of a bulk transfer of data from one location to another. As such, it's very efficient and extraordinarily scalable, from everything from moving a T1 to literally tens of terabits. One of our systems at full capacity can move the entire Library of Congress in less than 5 seconds, right? So that sort of bandwidth is capable is possible at the layer 1 layer, at the physical layer. But there are also requirements where we need to, as I mentioned before, detect that customer, understand what services they purchased, and then configure those services on the fly, deliver that high level of quality so they keep happily paying their bill month after month after month, right? Excuse me. So those services require layer 2 switching, also known as Ethernet, or layer 3 routing, okay? Routing is the layer that the internet runs on, essentially, right? This is routers or boxes that are like traffic cops. They move data from one location to another. They're very high touch, very complex, and very high service delivery, right? As such, they're expensive. So if you look at my upside down triangle there, what I'm doing is kind of drawing a picture for you where the money gets spent when you build a network. And it all depends on what you need to deliver. If you have a network, like I'm going to show you here in a moment, where you just need to move data from one location to another, and all of the customer sorting and high touch, high service delivery information is done outside of your transport network, then you just need big pipes, and you need big reliable pipes, okay? You build a layer 1 network, an optical network. If you need more of that high touch, high delivery feature built into your transport network, you add layer 2 or you add layer 3. Going into what those individual layers do is outside the scope of this conversation, but we're certainly happy to have that conversation with you. I think, simply put, there are a lot of arrows in the quiver, right? Depending on what you need to do and what your vision is for your network, there's a tool, and there are examples out there of how we go about doing that. So here's the example I was talking about. This is Georgia Transmission Corporation, and I'm going to tap my colleague, Cal Calenda. This is his customer, to talk about what Georgia Transmission has done with our Apollo optical solution.
Thanks, Jack. What this is a network that's been around for a bit. Originally, Georgia Transmission, who's a power generation company based in Atlanta, they cover about 70% of the geography of the state of Georgia. They service 38 electric membership co-ops. They provide them with power. And what they've done is managed to build out fiber to each one of these co-ops headquarters and any substations that they pass along the way. Initially, the network had been built in order to provide usage and billing data, but it's morphed over time. It has gone on to leverage all of the opportunities for residential broadband that some of the co-ops are getting into. So they now do internet backhaul, DIA service backhaul at 10 gig, 100 gig, and 200 gig for some of their EMCs. And they're also doing some of the I guess I would call it being secure. Some of the services they're encrypting at layer 1, because of course, being a larger company and a larger network, they're worried about things like NERC and FERC regulations. So they're using an encryption algorithm as well. Thanks, Jack.
You bet, Cal. Thank you. So moving on from that layer 1 optical network, what we call Apollo, like you see in the Georgia Transmission Network, we can add that layer 2 and layer 3 feature, right? So this is what I call my wedding cake or Frisbee kind of diagram. Essentially, this shows you in a theoretical sense what the network, what a layer 1, 2, 3 network looks like with management on the top, right? So typically, you will build that optical transport network underneath, which provides the raw horsepower, if you will, to move data from one location to another. Think of the optical or Apollo layer as the superhighway, okay? And then what we call Neptune, which is the switching and routing capability, that's where you put the cars and trucks on the highway, right? So these are the more complex, but yet more service aware and service delivery oriented devices that can provide those higher revenue services to your customers, right? The key words here, these are, they're very, like I say, they're very complex devices, but the key word is managing that complexity appropriately. Because to a certain degree, you're going to need some of that to deliver the high revenue services, right? If that's your vision for your network, right? So a device that, while it's complex, can also be somewhat autonomous in providing protection schemes, right? So that it auto detects if it needs to fail over from one location to another or from one route to another. That it automatically reserves bandwidth for your important customers, that sometimes they'll get on and do a lot of business. Say, for instance, a work at home CEO is going to have a lot more from, say, 7 to 8 or 7 to 7 during the day, and not so much in the evening when everybody else comes on and starts looking for Netflix and other types of streaming services. So a device like a Neptune will go out there and detect those usages, apply appropriate what we call bandwidth profiles to make sure that the work-at-home CEO has everything that he's paying for and guarantees it, while then later allowing those delay-tolerant services like streaming Netflix and so forth to occur over that same bandwidth, right? So somewhere in the mix of building that cost-effective optical backbone and then the high degree of service awareness and service delivery is the answer for you. At the top is management, right? And that's an absolutely critical part of what we're doing, and I've got a couple of slides specific to that coming up here. So I wanted to throw this map into, a lot of you are going to be familiar with this map. This is a generic, but a pretty widespread, ubiquitous structure for delivering broadband out to the end customers, right? So that base layer of optical delivery typically occurs right here between your border routers, the routers that face the internet, right? And then if you have routers internally in your network, and then the service aggregation here on the left, that is basically aggregating all of your OLTs, your other broadband delivery platforms that are actually attached to multifamily housing or residential or business or what have you, right? So there's that edge device, which is out there attached or on premises for your end customer. And then all of that comes back to an aggregation device, which can then detect which customers are coming in, which ones need to get the HOV lane for fast track back to their resources, and which of them are best effort type traffic, right? So that high degree of touch starts at the service aggregation layer and at that device. So this is what we've been talking about so far here in my presentation, is everything from the backbone, which is the optical network over fiber, and then devices at the layer 2 or layer 3 level that are aggregating your broadband customers, whatever they are, and then forwarding all of that information up to your border router, because here, of course, is what your customers are looking for, right? They're looking for Expedia and Facebook and Google and their data centers and VPNing to their home networks, and in the evenings, Netflix and other streaming services and so forth, right? So this is, it's generic. Everybody's is a little different, right? But this kind of gives you an idea of where all of this fits in the broadband map. All of these are tools. If you look in the lower left-hand corner here, these are those arrows in the quiver, right? These are things to consider when you're building a network. You may not need all of them. You may only need one or two, or you may want all of them. But we certainly have customers that are using all of these features. But these are things just to kind of jot down, do some research on if you're not familiar with them, or feel free to ask us, and we're happy to walk you through it. So here's another profile. This is a profile of a customer that has more than just the simple optical layer. And I'm going to let Cal step in again. This is, again, one of his customers, and kind of walk you through this one.
Sure, these are the wonderful people at North Central Electric Cooperative in Olive Branch, Mississippi, where previously we talked about a large statewide network. This one's a little bit more compact, but it did have some challenges, right? When you're working in rural environments, there's often a great distance between pockets of broadband users, and that's what these folks were running into. They had to, first of all, put together a reliable and resilient layer 2 ring, because that's sort of what the GPON is handing off to them, and then transport that over greater distances. So they also had to have an optical layer to overcome those distance limitations. And because their fiber was so spread out and so key to them, because it is one big fiber ring, they also wanted to have an integrated OTDR fiber health management application, which we were able to provide them. Basically, what that did was allowed them to predict within a meter or two of where there was a fiber break. So if there was a fiber break, they're dispatching to a repair, not to a go out and try to find it kind of thing, looking for the backhoe in the middle of the field or the tree that fell over and took down the overhead fiber. The security and the reliability are there for them. And this network is growing. It started off as a multi-10 gig ringed network, and it is growing to 100 gig. All the demands of those Thursday night people watching prime football, it just sort of pushed them up into the 100 gig range.
And that actually underscores a point that I made earlier, and I'm going to underscore again, and that is, if you have a chance to build a network today, you want to build a network that's going to scale with you for years to come. Typically, when we put in a ribbon network, we are confident in saying that it's going to serve you well for at least 10 years, right? Now, depending on what type of business you are, you may have either a short or a much longer right down on your investments, right, on your physical plant. As I mentioned before, we started out building equipment for defense agencies and utilities around the world. Generally, those are very high demand, high expectation customers. They take a very dim view of having to replace things every 3 years, right? Well, the design features that we've put into the equipment are well matched to what we're seeing now with the tremendous growth in bandwidth, and then in those diversified services, the high revenue services, right? Those are coming, right? And you want the network you buy today to be able to serve you, even if they're not going to come for 3 or 4 years. We don't expect that you're going to be replacing a ribbon network in 3 or 4 years, right? So build it today with the money that you have today, and the demand coming down the pike. Some of you are going to have the demand today, right? But that demand is coming, and you want that network to be able to match your requirements without having to forklift it out and do it all over again. Regarding installation, I'm going to draw your attention to that bullet point in the lower right. Something I just want to put in your mind is that for a lot of you, you may not have the internal expertise to build a network like this, right? You may not have the personnel, right? Because it takes a significant amount of man hours to get this thing in, get it turned up, and move it forward, right? We've got you covered there. Ribbon provides full turnkey services for all of this, right? So if you simply want to hand it over to us and let us manage it, project management, logistics, shipping, design, the entire package, or any piece of it thereof, then we've got you covered with folks right here in the United States. So let's move on to the management piece. This is a critical element because, as I mentioned before, a couple of times I've used the word complex. I don't want that to scare you. I want that to impress upon you that the devices need to be highly capable. It's another word for complex, right? They need to be very capable, very adaptable to what type of services you're going to develop. Now, with the typical way that networks have been built up to the past couple of years, you end up with lots of different screens, and a different screen, a different management system for every single application. So you end up with what we call swivel chair management, where you are looking over here, or you're on the phone talking to your field tech with an OTDR, trying to find out where the backhoe is, right? And then over here, you're looking at your security application. And here you're trying to hammer out on your switches and on your routers and so forth, right? This is no way to run a network, right? It requires multiple people to have multiple skill sets. You're always trying to figure out which vendor is responsible. You can end up in finger pointing situations. All of that has to go away for a network to operate at peak efficiency. And also, quite frankly, that's what you have to have in a rural space because you're all experts. Better to have one screen that provides the majority or all of what you need and be able to manage it all from wherever it is you are. So this is what we call Muse. It is an example of a total network management solution. Yes, it has the topology map. It provides it in 2 dimensions. It provides it in 3 dimensions. Why would I need a 3-dimensional design or a 3-dimensional topology? Because we have the optical layer, we have the switching layer, and we have the routing layer. So what happens, for instance, when you get a fiber cut? Well, layer 2 and layer 3 get cut off. Those 2 routers that were talking to each other over that fiber stop talking to each other over that fiber. And then they have protocols that say, oh, I got to find another way to find my friend over the network, right? So that's, that's what routing protocols are for, and convergence and all of that, right? Well, the problem is not that your routers have switched over. Your routers switch over because that's what they're supposed to do. The problem is that fiber's cut. Well, if you're just looking at a two-dimensional map, it may not be immediately apparent where that problem is. Is it layer 1? Is it layer 2? Is it layer 3? So being able to take this and turn it into 3 dimensions gives you that additional capability to see what's really going on your network. The topology that you're looking at here can be subdivided. If you have different techs or different folks that are responsible for different parts of the network, then you can separate their viewing screens. There are multi-layer user roles, and so you can have super users and then, say, for instance, NOC technicians and so forth. At any point, you can double click on one of these nodes out there, and it will bring up the shelf diagram, which shows you exactly what the face of that device looks like, as if you were looking at it in the CO or in the substation. It'll show you where the cards are. You can double click the card. It'll bring up that card, show you which ports are active, which ones are inactive, which ones are available for provisioning. It's all context sensitive based upon the task that you need to perform. So this is a one screen, sort of a single pane of glass, if you will, for everything you need to do on your transport network. Analytical tools as well, showing you where your signal strengths are strong, where there might be some problematic issues that you need to go and do preventive maintenance on. It keeps all of that performance data historically, so you can do a birth certificate when you first turn it up, and then run it in an automated fashion once a month, once a quarter, once a year, however it is you decide to run it, and then do a stare and compare of graphs over time to see how is my network performing. So the tool that I'm talking about here is Muse. Multiple different viewing screens. So yes, there's the topology view, which everybody expects. As I mentioned, in the lower right, you'll see the shelf diagram. This is one of our larger optical shelves that shows you exactly what's in that CO and in that shelf. And then in the upper right, you see a dashboard of what we call widgets. Each one of those little screens can be customized for what you need to see. For instance, show me my top 5 users in terms of bandwidth. Show me my problematic areas. If I have any areas that are running slowly, not meeting their SLAs, and so forth, then show me those. You can customize these widgets so that for a CEO or a network manager who really just needs, they're not doing day-to-day provisioning, they just need to see the health of their network, right? These are like the monitors in the hospital, right? That are just showing you exactly how healthy your network is at a glance. Provisioning, service restoration is all automated. It's point and click, so you want to create a service from one location to another. You click on your starting point, you click on your ending point, and it will just ask you questions. What type of service do you want to provide? What kind of bandwidth are you providing? Are you putting any higher level services on it? Are we configuring encryption, protection, what have you? And then it will map all that for you. And then if you're good with it, you just click enable, and it will go through and build all of that for you from beginning to end, A to Z, all the way across the network, right? So really a tremendously powerful tool that enables your smaller staff to do a lot more with a very high touch and high service aware network. This is a feature that while it's not expensive at all, in fact, it's really quite cost effective for what it delivers. It's important to bring it up because it really makes a big difference in the rural spaces where you often have miles and miles and miles between locations, right? Fiber, and then there are those roaming backhoes that we occasionally have to deal with, right? And weather and other effects, right, that can affect our physical plant. And so there is an application that we can build into the system for remote monitoring. And this goes everything from monitoring transmit and receive levels to other DWDM characteristics. DWDM is multiple wavelengths of light over a single pair of fiber. There's a number of optical physics capabilities built into that and metrics that we can monitor for you on an automatic basis. And then really most critically is the OTDR module, which is automated and built into the network. So, you know, traditionally what we've done is when a fiber gets broken, you start getting alarms. You may get calls on the help desk, customer complaints, what have you. But certainly you're going to get alarms saying, hey, something's wrong here. Well, what's the problem there, right? Now, I'm not getting data moving from, say, point A to point B over a particular span. So is that, are the pluggable optics broken? Is there a fiber cut? Did my router die? You know, did somebody plug in a fiber jumper into the wrong port? We don't have any idea what it is, right? So now starts the troubleshooting, and of course the clock is ticking, right? Now, if your network has been provisioned for automatic protection and service restoration, then you're good. It gives you more time, but you still have to get that fixed in a short period of time. If this is a fiber that has data on it that is not protected, you're losing revenue, right? You're violating SLAs, all sorts of negative things are happening here. So the clock is ticking. With this tool, in an automated fashion, if there is a fiber cut, then it will do an OTDR shot and it will report to you either via email or text that you have had a fiber break, and it will tell you within a meter or two exactly where that fiber break is. So you will be rolling a truck, but it won't be a tech or two out to the CO with a handheld OTDR meter to try and figure out where the problem is. It'll tell you exactly where the break is. So you'll roll a truck, but it'll be to start splicing that fiber back together again, right? So usually within just a few minutes, it will tell you that there is a problem and you can start the healing process, if you will, as opposed to that long troubleshooting. And Cal, I'm going to call on Cal here because he's got a good customer story.
Yeah, there was a real practical application, and like you said, Jack, the OTDR function can pay for itself rather quickly. Not everyone owns all of their fiber. Sometimes you lease fiber, sometimes you swap fiber. We have one utility customer in the Southeast who on one particular link went through 3 different fiber providers. And when there was a break along the way on that particular route, they would have to dispatch 3 crews to go and find that problem. And they would get 2 invoices for no trouble found and 1 repair invoice, and the costs were stacking up. So we put this Light Pulse OTDR application into their network, and the first time they used it, they got rather excited and called me on my cell phone at 3:30 in the morning to let me know that that fiber break was exactly 72 kilometers south of Jacksonville. I promptly thanked them for that and wished them well and told them I'd call them back at 8:30 in the morning. So it really is a wonderful tool, not just the location and saving money, but the historical trend analysis as well, right? It's better to know that a problem's coming and fix it before it occurs.
Yeah. Thanks, Cal. So the way this works, it's actually built into the network, and the application is built into Muse. And the way that works, it works, you know, normally OTDR, you've got to take your traffic down to use an OTDR. This works because its wavelength operates outside of where all our traffic runs, right? So typical traffic tops out at about 1550. right around there, 1550 nanometers. This operates at 1610 nanometers. So it can operate in a parallel fashion in service without affecting your traffic at all. So you are getting a 24/7 OTDR that you can access at any time of the day or night. Okay, so I'm going to start wrapping up here. One thing I want to emphasize is the critical value that having a US-based support team can bring to you. Not only are they in roughly the same time zone, right, but they speak your language, they understand what your service requirements and service offerings are going to be because they're familiar with the market. In our case, our entire support team to support everything in North America is based in Fort Lauderdale, Florida. The leader of that team has been with us for 34 years and is one of the most responsive and innovative support team leaders that I have ever seen. The level of white glove support that they provide in a very cost-effective fashion, I think, is going to win you over. And we are happy to introduce you to him and to his team. We provide 24/7 support, full project management from beginning to end with a dedicated project manager. Our implementation team and our training services are also hosted out of Fort Lauderdale. And then there's also a very large lab there and also one in Plano, Texas, where we can replicate the problem. If you're concerned about interoperability with another vendor's equipment, we have had customers ship their GPON devices, their XGS-PON devices down to us, and we can put them in the rack and we can implement a test plan that you give us. As our team lead down there, actually he's the vice president in charge of that area, as he likes to say, my lab is your lab, right? If we need to do something like that, we are happy to do it for you. And generally those services are available at no charge, right? It's to everyone's benefit to make sure that your network is operating at peak efficiency. Inevitably, from Ribbon's perspective, that means working and playing well with others, right? You're never going to have all one vendor from one end to the other. So that interoperability piece is absolutely key. We want to avoid finger pointing. We want to make sure that things are optimized. We look at the other vendors in the network as partners. Yes, in some cases they're competitors, but if they're your devices, then they're our partners to help you deliver your services. Okay, so in summation, this is what I've been talking about here is a coming together of multiple forces here, right? The demand, which we talked about extensively at the beginning of the presentation, where we obviously are seeing tremendous bandwidth demand and have been for several years. But now with the new protocols, new capabilities, you're going to see much higher demand for those high revenue services, right? The high touch, high service awareness opportunities to charge more. The technology is available today. We have seen more development in hardware and software to advance speeds and capacity, and that creating that service experience for your customer. We've seen more of that in the last few years than in my entire 20-year career in this space, right? It's really quite remarkable what's out there today. And certainly we're happy to talk to you more about the specifics there. And then funding, again, right? $100 billion worth of public investment across these United States. It's really unprecedented, and it presents a great opportunity for us to bridge that digital divide and also build out our infrastructure for our own use, and then also to serve our customers. Okay, so in closing, I just want to highlight a couple of things. Ribbon creates standards-based IP and optical solutions, right? We cut our teeth on the military agencies around the world, where many of those are in place and managing political boundaries and military capabilities, as well as utilities around the world, smart cities and the like. We are globally deployed in most of the countries around the world, quite frankly. That number jumps up and down, the number of countries that exist, but we're in over 140 countries today. Critically, we don't charge any persistent licensing fees on our software. So you will never get another invoice from us when you buy our software for a Ribbon product. Once you buy it, it's yours, right? Of course, there's maintenance and support as time goes on for additional upgraded features, and those are available at your option. But when you buy a software solution from us, you own it. It's one and done, no more invoices. You have to lease your interfaces from us on an annual basis. Doesn't work that way here. As I mentioned, 100% US-based support. We will not pass you off to an overseas call center. Everything will be based right here in the United States. And then finally, I mentioned early on, a number of these public funds have a requirement that the equipment, the solutions that you purchase are Buy America Act compliant, right? So if you Google Buy America Act, it'll give you sort of the whys and wherefores there. We tend to bring the lawyers in when we have to look at all of that, the way legislation is written. But the Cliff Notes version of this is that the solution you buy needs to be from the United States, manufactured here, or it needs to be from a country that's friendly to the United States, right? And you can probably guess who those are, right? So there's about a dozen different countries that all fit within the Buy America Act capabilities. Everything that we are talking about here today is Buy America Act compliant, right? So that checkbox is marked. And then finally, we've had a kind of a logistics snarl as a global community, right? Brought on by COVID and other factors. But if you've been trying to source equipment of really any type, I think it's eggs currently that we're having trouble getting. Logistics have been a problem for the past few years, right? Well, through a series of good decisions, solid planning, and then some luck, Ribbon has bypassed all of that problem, right? Part of it is shortening our supply chain, moving it to friendly countries, things like that. But we are running about 10 to 12 weeks on everything in the portfolio, from PO to hitting your dock. We are running, 2.5 to 3 months to deliver everything in the portfolio, and that's been consistent for the past year. And if anything, I see it getting better. So if you are under a time constraint, and a lot of these government contracts, these government funds are coming with a deadline to get things up and running and then proven in and tested. If you're facing those deadlines, then give us a call, because we can probably help you out with a short delivery window. All right. Well, thank you. We have talked really across the board here about the unprecedented situation that we find ourselves in. Very positive today, and a very bright future moving forward for broadband in America. I appreciate your time and attention. If we can answer any questions for you, we're happy to do that, either now or I'm going to give you our contact information here. Take a screenshot. Feel free to give either of us a call. And we're happy to go into more detail on any of this. And again, I'd like to thank Cal and Lance and Elizabeth for joining me here this morning. And I'll turn it back over to you, Lance.
Thank you, Jack. Yeah, we did have a couple questions come in. So as Jack mentioned, feel free to type those in now to the Ask a Question box, or you can just reach out to Jack or Cal. The numbers or emails below and ask your question there. But one of the questions that came in from Thomas about the demo process. He wanted to know what's that demo process like. Elizabeth answered that question, but so Elizabeth, I don't know if you want to speak to that answer, but wanted to understand what that was like for the demos.
Sure, I can do that. So yeah, for Muse demos, or if you're wanting to see the management system, we can definitely set those up. They're usually virtual, and we work hard to emulate, close to what you're trying to deploy as possible. That way it can be in perspective of what you're thinking of trying to solve in your network. So we can do that, and if it's a hardware type of demo, which the question alluded to, just give us a call. Give Jack or Cal or myself a call. The invitation went out underneath my name, so you should have my contact information too. Give us a call. Let us know what you're trying to solve. I'm sure we can work on something together there.
You bet.
Great, thanks, Elizabeth.
Thanks, Elizabeth.
Another question was about backhaul. Do you guys, does Ribbon have a solution for cell tower backhaul?
Yeah, we do. As a matter of fact, one of our largest customers here in North America is a cellular backhaul customer. They are currently lighting up 2,000 kilometers of fiber with both our optical and our layer 2 and layer 3 Neptune solution. They are backhauling about 1,100 towers these days to that primary backhaul backbone that runs through 5 western states. So it's a very highly resilient network. Everything is protected there in a sub 50 millisecond fashion. So in other words, sub 50 milliseconds, everything will fail over to a backup path. And of course, it covers a very large geographic area. So the optical layer where I can amplify a signal to get, from one location to another, even up to 200 kilometers away, is really quite valuable out here. I'm in Colorado, so we call it the big square states out here in the West, right? It's a long way from here to there, right? So that optical layer is pretty critical out here. But yes, our Neptune solution, speaking specifically to cell backhaul, is ready today for not just 4G but 5G. Those of you that have looked into 5G are going to see that it's really a quantum leap forward. It's not just more bandwidth, but it is an entirely new architecture in terms of its structure, and the Neptune devices are ready today to support that structure in terms of timing and hard slicing and so forth.
Great, thanks, Jack. And the last question we have is really just kind of, you spoke about it during the presentation around timelines and delivery, supply chain. Just wonder if you can talk a little bit more about that.
Yeah, so I mentioned that it was good planning and luck, and I guess just to say one more thing about it, and I think I mentioned this, but we started moving our supply chain, shortening our supply chain, and moving out of certain areas of the world for other reasons prior to COVID even showing up on the world stage, right? So we were already outside of that logistical snarl that was coming. Obviously, we had no way to know that COVID was coming, but so that's where the luck comes from, right? Is that it was good planning. We moved and shortened that supply chain, so now we're able to put our hands on components, manufacturing. That whole logistical supply chain was well established before COVID even showed up, and so it's the bullet that you dodged before it was even fired, I guess, is the way to talk about it, right? So that's the truth behind, or the reality behind, that statement and why we've been able to deliver on very short time frames, you know, pretty much throughout the entire affair. So yeah, good question.
Excellent. Okay, well, that's all we have so far today. Again, as Jack mentioned, appreciate everybody's time. We'll be getting an email out here in a little bit with a link to the replay, as well as the copy of the slides. So be on the lookout for that. Jack still has their contact information on the screen. Elizabeth put hers in the chat area. So take a moment to jot those things down. And we just appreciate your time today, and be on the lookout for the next webinar, I'm sure coming soon. We thank you, and we'll talk to you soon. Take care.
Thanks much.